Hey Math Kids, today we're going to do 4-point C and we're using probability to evaluate outcomes. So we're going to play a game. So we have a dice. So dice number 1 is 1, 1, 1, 3, 3, 6, 6, 6. Okay, dice 2 has 2 2s and 4 5s. Okay, so they're not standard 6-sided dice, but they are 6-sided dice. When the dice are tossed, the set of dice with the highest number wins. Which set of dice is more likely to win? So we're just talking about like reasoning on how this would work out. So we have a 1, 1, 1 and a 6, 6, 6. So basically we reduce the outcome. We're either going to get a 1 or a 6, and it's just as likely. 1 or 6. Now this one, we're going to get a 2 or a 5. But it's weighted a little bit different. Now we want to compare like what happens. So half the time we're going to roll a 1. And if we roll a 1, it doesn't matter what they roll on this dice because we're going to lose if we're rolling dice 1. So half the time we will lose for sure. Now if we're rolling dice 1 and we get a 6, which is half the time, we'll beat any of these rolls. So we will win for sure. So this game is actually reduced to just whatever happens on dice 1 determines what happens. And so it's an even game. So the question was, which set of dice is more likely to win? The answer is neither, because they're the same. Same chance. Okay, but dice 2 is actually irrelevant because the game is determined by dice 1. Okay. Vicky and Joyce are playing a dice game with 2 dice. Vicky gets a point. So we got Vicky and Joyce. So Vicky gets a point if the sum of the numbers on the dice is even. Sum is even. Joyce gets a point if the sum is odd. Okay. Is this game fair? So is this fair? So if we quickly write out the outcomes on a dice, so 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and then we write the sums. So it's going to be 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8, 2, 3, 4, 5, 6, 7, 4, 5, 7, 8, 9, 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, 8, 9, 10, 11, 12. Okay, so this is just a visual way to go through it. You don't have to do it this way. But now I'm going to circle, so all I did was like 1 plus 1 is 2, 2 plus 2 is 4, 2 plus 1 is 3. I just made kind of a grid of all the possible outcomes. And if I just go diagonal, I can circle all odds or evens by doing this. So I circled all the odds. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there are 18 ways to get an odd sum. Okay. Now, if I do the same thing, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There are 18 even And so the game is fair. So the answer is yes. The game is fair. Now it says they get tired of this game and change the rules. Now Vicky gets a point if the product is even. So they change it. Now it's product. This one's changed product too. Okay, so we can't use that same table. Let's see. Yeah, we can. Let me just make this bigger so I can erase this better. We'll use this space. Okay. So we do 1 times 1 is 1. And then 2, 3, 4, 5, 6. So nothing too crazy there. Now we just go multiply each of them by 2. So 2, 4, 6, 8, 10, 12. Multiply them all by 3. 3, 6, 9, 12, 15, 18. 4, 8, 12, 16, 20, 24, 5, 10, 15, 20, 25, 30, and then 6, 12, 18, 24, 30, 36. We go through and we circle all the odd numbers. So odd, odd, odd. None of those are odd. Odd, odd, odd. None of those are odd. Odd, odd, odd. None of those are odd. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's only 9 odds now, which means it has to add up to 36. And so if we count these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. It's going to be 27. And so this is not fair. Not fair. Okay. So moving on. So for this one, I'm going to draw a plot. 1, 2, 3, 4, 5, 6. It's probably good. Just make some of this. Okay. So how many are these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So the plot represents the number of points an individual player scores in each of 12 soccer games. Is it likely that at the next game they'll score 6 points? Okay, use probability to explain your answer. So if we look at the probability of each of these, just kind of the experimental probability. So probability of 1 is going to be 1 out of 12. Probability of 2 is also 1 out of 12. Probability of 3, 2 out of 12. Probability of 4, 4 out of 12. Probability of 5 equals 3 out of 12. And probability of 6 is 1 out of 12. So it is definitely most likely that they'll score 4 points because that is the most probable based on what they've done. And so I would probably say something that it is possible to score 6, but not probable because it has the lowest probability. on the plot. Specifically, it's a 1 out of 12. Or if we do 1, 1 divided by 12, it's about an 8% chance, which isn't very likely. Okay, and the last one I think I can do in this little space right here. So we're taking a true-false quiz. Could we, let's see, what do we need? You need 70% to pass. Can you pass by guessing? So I would say no, because true or false, if you purely guess, randomly select each time, you will get 50% on the test, which is lower than 70%. And then the question also asks, how could you simulate this? Well, we could simulate a 20-question test with coin flipping. So if we flipped a coin 20 times, that could act as our thing. Because actually that's how we could answer it on a real 20 question. We flip it, say heads is true, tails is false, which actually it might make more sense to do it the other way. Tails is true, heads is false. Okay, if you need additional help, come to Math Lab. Until then, calculator.